A remote control toy car is moving over a horizontal surface. It moves in a straight line through a point A. It is initially at the point with displacement 3 meters from A. Its velocity v at the time 2 seconds is given by. Oh, okay, so it's these kinds of questions where you've got to use calculus because you haven't got constant acceleration. Find an expression for the displacement at time t seconds. Okay, so first thing we need to have noted is that to go from displacement to velocity to acceleration, do you know what you have to do if you're going from displacement to velocity?
And would you have to integrate?
Nope, the other one.
Oh, differentiate.
Yep, that's it. So differentiate. That is supposed to say differentiate, and also differentiate for going from velocity to acceleration. When you go the other way, that's when you're integrating. And also this way. So with this one, we've been given that v equals 0.6 times 2 plus t minus t squared. So when we integrate this,
Oh,
because we're going,
0.06.
oh, yep, you're right. 0.06. 0.06 times 2 plus t minus t squared. So we're trying to find an expression for displacement. So we need to integrate. So our displacement r is going to be the integral of v dt, which is going to be the integral of 0.06 multiplied by 2 plus t minus t squared dt. But because it's all being multiplied by 0.06, we can write that as 0.06, taking the constant out, multiplied by the integral of 2 plus t minus t squared dt. Now we can integrate this, and that's going to give us 0.06 multiplied by, and then we have 2 plus t minus t squared. Oh, wait, no, what am I saying? Sorry, makes no sense. Integrating 2 becomes 2t. Integrating t becomes t squared over 2, and integrating t squared becomes minus t cubed over 3. So remember to add 1 to the power, divide by the new power. For t squared, add 1 to the power gives you 3, divide by the new power of 3. And we need our plus c. So the constant could be inside the bracket or outside the bracket. It doesn't actually matter because it ends up being the same expression at the end. So we've got this, and that's what r is equal to. But to work out the plus c, we know that initially the toy has a displacement of 3 meters from A. So therefore, we know that initially means when t equals 0. And displacement being 3 meters means that r is equal to 3. So therefore, we can substitute all of that in. So we get 3 for r, and that equals 0.06 multiplied by, every term here has a 0, so that actually becomes 0, and then plus c, which results in c being equal to 3. So our expression for the displacement is r equals 0.06, open bracket, 2t plus t squared over 2 minus t cubed over 3 plus 3. And that's our final answer. Okay, so in this question, use g equals 9.8 meters per second squared. At time t equals 2 seconds, the toy launches a ball which travels directly upwards with initial speed of 3.43 meters per second. Find the time taken for the ball to reach the highest point. Okay. Does it even matter that this happened at time t equals 2 seconds? So I was going to start incorporating horizontal movement. It's not going to change anything about the upward motion of the ball. So nope. Okay. Cool. So this is just a SUVAT question now. So writing up my SUVAT. Okay, it's important that we pick a direction to be positive and a direction to be negative in terms of up or down. So anytime you've got questions to do with directions, you always need to assign positive and negative to one of the two directions. So I'll let you guys pick.
Can we make a down, down negative and up positive?
Okay, so down is negative and up is positive. So we've got the initial speed, because it says the ball travels directly upwards. So the initial speed is 3.43. That's up, so it's positive. What else do we know? We also know that acceleration due to gravity, that always acts downwards because it's, acceleration due to gravity. So that's minus g, or minus 9.8. And if we're trying to get to the highest point, we know that at the highest point, v is going to equal 0. And if we're trying to work out the time taken, well, we've got u, v, a, and t. So we've just got v equals u plus a t. We could substitute in the numbers now and then rearrange for t, or we could rearrange first. I think I'm just going to go for the option of rearranging. So v minus u over a equals t. So I've got 0 minus u, so minus 3.43, all over minus 9.8 is equal to t. So therefore t equals, and then we use our calculator.
Yeah. About 0.35.
Oh, perfect. Okay, 0.35. Is it exactly that?
Yeah.
Nice. So t equals 0.35. So 0.35 seconds. I'm assuming there's a part C to this.
No.
Really?
No.
Oh. Why did they give us this piece of information then? It's very unlike exam questions. Is this an exam question?
It is, but it's like, it's a booklet of just questions.
Okay. It's very interesting that they gave us this at time t equals 2 seconds, because